Hello everyone, my name is M. Ganeshmani, USN 1BE22EC056, pursuing my BE at Shri Venkateswara College of Engineering in ECE stream. So the course name for today's video is Digital System Design Using Verilog and the course code is BEC302. The contents that we are going to be looking in today's video is sequential circuits and the industry application of sequential circuits. So this is the topic for today's video. So let us understand first what is sequential circuits. Definition: sequential circuits are digital circuits that store and use the previous state information to determine their next state. Unlike combinational circuits, which only depends on the current input values to produce output, sequential circuits depends on both the current input and the previous state stored in the memory element. Sequential circuits are commonly used in digital systems to implement state machines, timers, counters, and memory elements. The memory elements in sequential circuit can be implemented using flip-flops, which are circuits that store binary value and maintain their state even when the input is changed. So this is the definition of sequential circuit. And there are two types of sequential circuit. One is synchronous sequential circuit and the second is asynchronous sequential circuit. Asynchronous sequential circuit. These circuits do not use a clock signal but use the pulse of the input. These circuits are faster than synchronous sequential circuit because there is clock pulse and change their state immediately when there is a change in the input signal. We use asynchronous sequential circuit when speed of operation is important and independent of internal clock pulse. Synchronous sequential circuit. These circuits uses clock signal and the level input or pulse. With restriction on pulse width and circuit propagation, the output pulse is the same duration as the clock pulse for the clock sequential circuit. Since they wait for the next clock to arrive to perform the next operation, so these circuits are a bit slower compared to asynchronous. Level input changes state at the start of an input pulse and remains in that until the next input or clock pulse is applied. So as we can see, this is the diagram in which we can see the input level and the output pulse level is shown, but this performance totally depends on the clock pulse, which is shown here over here. So this is how the synchronous sequential circuit works. Now let us understand the application of sequential circuit in the industries. As we can see, sequential circuits is used in various forms such as shift registers, flip-flops, counters, analog to digital or digital to analog converters, clocks used as registers inside microprocessor and controllers, as well as timers. So these are some of the examples of sequential circuit in industries. So let us learn about it in brief further. Counters. Electronic counters can have many different functions for counting, controlling, and time monitoring. These are the vital roles that are played by counters in the industries, and these includes arithmetic functions, controllers, batch counters, count virtualizers, event counters, preset, pulse counters, delay cycles, positions, indicators, rate meter or technometers, and time meters. Reset capabilities of the machine depends on the model, such as none, manual, remote, or auto reset. And let us understand the types of counters, that is preset or predetermining counters, electrochemical counters, electronic counters, rate indicators, process indicators. Digital to analog converters. A digital to analog converter DAC converts a digital input signal into an analog output signal. The digital signal is represented with a binary code, which is a combination of bits 0 and 1. This chapter deals with the digital to analog converter in detail. This is also used in vice versa format. Uses in industries: video encoder, audio amplifier, display electronics, data acquisition system, motor control. These are some of the day-to-day examples in which DAC is used. Clocks. The clock signal performs the synchronization of the state of memory elements in the case of synchronized sequential circuit. The output in this case is either stored in latches or flip-flops in the memory device. Uses in industries. Memory unit. Clock signal controls the output of the sequential circuit. This is, it determines when and how the memory element changes their output. If a sequential circuit is not having any clock signal as input, the output of the circuit will change randomly. Flip-flops. The flip-flops are basically the circuits that maintain a certain state unless and until directed by the input for changing the state. We can construct a basic flip-flop using 4 NOR and 4 NAND gates. As we can see, this is an example of 4 NAND gate flip-flop. So the types of flip-flops are SR flip-flop, JK flip-flop, T flip-flop, and D flip-flop. Industry uses application or the uses of flip-flop in industry, that is in communication system, memory, and registers, where this plays a vital role in storage of elements by using the previous state as well as the reset state or the current stage, which is known as preset stage or the set stage in the field of Dsdv. Thanks for watching this video. Please do like, share and subscribe to my channel. Hit the bell icon for further notifications. Share all your views and comments in the comment section below. Stay tuned for more upcoming videos. Goodbye.